That little 3D printer just might change the world. Seriously. So I've been playing around with this pre-production LDO Positron V3 for about a week now. And in this video, I'm going to give you my first impressions, an overview of what the heck this thing is, and why I think it's going to change not only the 3D printing space, but possibly the world. Let's get after it. What is this thing? First things first, let's talk about what this thing is and how it came to be. I mean, obviously it's a 3D printer, even though it doesn't look anything like one. In the vein of RepRap, it's both open source and relies on a lot of 3D printed parts. But it has one major defining characteristic, and no, it's not the fact that it's upside down. This 3D printer is portable. And not just, let's put a handle on our small printer and toss it in the trunk port. Like, really portable. Let's throw it in a suitcase and fly to another country portable. Which, by the way, I'm planning on doing in an upcoming video, so get subscribed if you don't want to miss that. Now, I'd be remiss if I didn't give you a little bit of history and give credit where credit is due. The idea for this printer and its initial designs and prototypes come from a fellow content creator named Crawlin, whose explanation videos I will link below in the description. Now, his guiding design principle, as I understand it, was originally to develop a 3D printer so small and so portable that it could fit into a filament box. Yeah, one of these. That was a couple of years ago, and since then, LDO's brilliant team, in collaboration with Crawlin himself, have taken the concept and really run with it, upgrading it to this latest V3 version. They've changed a lot, from the bed type to the heater block to the belts, and just generally many aspects of the design, all in an effort to turn it from an idea into a commercial product that could be manufactured at a medium scale, similar to the way that LDO produces their Voron kits. And that's exactly the plan. In the coming months, LDO, through their worldwide reseller network, will begin offering these printers as kits, which you'll need to print out the plastic pieces for and then build on your own. Now, just a quick note, LDO actually shipped this to me fully assembled, so unfortunately I won't be talking about the building experience, more focusing on the perks and downsides of the finished product. Disclaimer. By the way, now is probably a good time to mention, and feel free to skip this chapter if you don't care about the ethical disclaimer stuff, LDO was kind enough to send me this kit customized to my favorite colors, free of charge, after hearing that my family and I had left Israel at the beginning of the war. Now, they've never paid me anything, and they won't see any part of this video or script before you do, but I do feel obligated to let you know that I have a major soft spot for the people and company that is LDO, both personally and because my two favorite printers, including my first ever sponsored printer, did come from them. I'm still going to try and be as objective as possible, but this shouldn't be construed as a review either way. I haven't had nearly enough time to actually play around with this thing to give a proper review anyways. What are the specs? Okay, so it's a portable printer, but what are the actual specs? It probably only churns out tiny, slow, low-quality prints, right? Actually, no. For reasons we'll get into shortly, this printer actually has a lot to offer. First, there's the print volume, which is a shocking 180 by 185 by 180. That's almost exactly the same as both the Prusa Mini and the Bamboo Lab A1 Mini, and 33% bigger in every dimension than the Voron 0.2, meaning that the total volume is about 240% bigger than the most portable Voron available. Then there's the speed. The official specs state that this printer can print at up to 250 millimeters a second with a travel speed of 350. But as with all top numbers, for reasons that we'll get into later, you're unlikely to actually print that fast. And by the way, acceleration values are an impressive 9,800 millimeters per second cubed. This printer features a Bowden tube setup rather than a direct drive extruder, as well as a ceramic 90-degree hot end with a Capricorn Bowden tube, so it can only reach 250C. The bed is a custom-made glass sheet with heating elements on the perimeters, which can reach a reported 90C. On the software side, this printer runs Clipper natively, meaning that you get vibration compensation, pressure advance, and even a very slick touchscreen interface. Overall, the entire printer weighs between 2,700 and 3,100 grams, which leads us to, how practical is it? Okay, so as you can probably tell from the specs, this printer is not just some gimmick or novelty proof of concept. It's a serious printer that can deliver serious performance and serious results. But how practical is it really? Well, there are a few different components and elements when it comes to practicality. First, there's the actual portability. Sure, the initial design challenge was to create a printer that could fit into a filament box, but given both the price and the fact that the entire bed is made of glass, you're unlikely to actually do that with thin cardboard. Instead, you'll probably want to carry this printer around in a much larger, much heavier Pelican case like the one that LDO does plan to include. And in case you're wondering, when everything is all packed up, this bad boy weighs in at 5.85 kilos and with the case has dimensions of 38 by 31 by 17.5. So no, I'm probably not going to just toss this thing into my backpack next to my laptop, but that certainly won't stop me from carrying it with me on public transportation, or adding a strap and putting it on my shoulder to go on my scooter, or even just tossing it into my suitcase for my upcoming international flight. Now, as someone who has tossed many different 3D printers into the trunk of my car for weekends at my in-laws, I can say that this is much more practical than any of the other 3D printers I've owned, and I've owned a lot. But that's just one element of practicality. The second element is deployment speed. Currently, it takes me about 3 to 4 minutes to fold or unfold this printer, including connecting all the different cables and electronics. But I've seen Kralin do it in under 90 seconds, and I'm confident that with enough practice, I'll be able to achieve the same. Now, it's important to note that there are no tools required to fold or unfold the printer and to adjust things like bed leveling. But it can be challenging, though not impossible, to maintain bed leveling and Z height every single time you fold and unfold the printer. So it might be fair to include just a few more minutes into that time figure for calibrations and getting it ready to print. Now that might seem like a lot of time in an era where you can just unfold and deploy a DJI drone in like 15 seconds, but it's really not. I'd say that being able to set up a 3D printer pretty much anywhere you have electricity in under 5 minutes is pretty astounding and super practical. Finally, practicality also means footprint. This printer, once it's fully set up, is really tiny considering its build volume, especially since the filament spool can be set somewhere else like the floor. Which actually leads me to a discussion of why this thing is upside down. Okay, hang on, because I do need to take a moment to thank this video's sponsor, PCBWay. Like you, I always prefer to 3D print as much of my project as possible, but for some projects there are just things that you cannot 3D print yourself. Whether that's industrial grade MGF nylon parts, CNC machined aluminum, metal 3D prints, or custom designed PCBs, the folks over at PCBWay have you covered. They offer a wide range of high-quality fabrication services at great prices with super fast turnaround. And if you don't know how to design PCBs or CAD models for CNC machining, don't worry, because they actually have a marketplace of ready-made projects that other people have designed and submitted. PCBWay has been a longtime sponsor of this show, and they're just great people to work with. So to check them out and support the people who make this video possible, visit the link in the description. Why is it upside down? Based on everything I've said so far, you're probably thinking, okay, great, but why is it upside down? What does that have to do with practicality and portability? And that's actually the most interesting part. It turns out that the upside down design is precisely the reason that this printer can do all the things it does. You see, unlike other bigger and heavier non-collapsible 3D printers like the Prusa Mini or the Voron 0.2, this printer does not have a rigid frame attached to the base. It also weighs between 1/3 and 1/2 as much as all those printers. So in order to achieve maximum stability and therefore better print quality at higher speeds, this printer takes advantage of the same principle that sports cars do. It lowers the center of gravity by putting the heaviest components such as the tool head and motors on the bottom, rather than hovering around on the top. And with this one design choice, it effectively eliminates the need for a heavy, rigid frame. But of course, that presents its own unique set of challenges. What's it like printing upside down? Like most of you, I assume, this was my very first experience with an upside down printer, and I had a lot of questions. First and foremost, how is bed adhesion? Don't your prints just fall off the bed? Surprisingly, they do not. Bed adhesion on the heated glass is actually surprisingly good, and while I was concerned about prints detaching by themselves after the bed had already cooled, I left the printer overnight and I was surprised to find my print still dangling there safely. Though I will note that I haven't had time to do any really heavy prints with some serious mass, so I'll have to report back on that one later. The second thing that's really different is, of course, overhangs. As you can imagine, because the forces of gravity are working in our favor rather than against us, overhangs on this printer are superb. In a past video, I rigorously tested the overhang performance of the Bambu Lab P1S, taking advantage of an open enclosure and the powerful auxiliary fan, but I was only able to achieve around 50-degree overhangs consistently. On the Positron, I was able to surpass an unheard of 60 degrees. So just imagine the amount of support material that you could save with this thing. So you probably won't be surprised to hear then that the Positron also excels at bridging. Here you can see a comparison between the Positron and the Bambu Lab P1S with its door and top cover open and the auxiliary fan. This is absolutely stellar bridging performance from the Positron, and it really comes down to the fact that the nozzle is basically acting as a support as you print out your bridges. Pretty cool. Other than that, printing upside down is honestly pretty much the same. It can be a little bit confusing to remember what's the front versus the back of the plate if you're trying to, say, orient your print in a specific way in order to face the cooling fan, but that's really no big deal and you get used to it. Also, thanks to the glass bed, I have to say that inspecting first layers is a real breeze. Those are a lot of the positives, but there are of course a few downsides from being upside down. First, removing things like purge lines without getting your oily fingers on the bed can be a little bit trickier, and it might be wise just to carry a little scraper with this printer. But that inconvenience really pales in comparison to the really big downside, which is failed prints. Inevitably, there are going to be some print failures, whether it's things getting knocked off the bed, layer shifts, or just general spaghetti. And when that happens, you just might be faced with some very tricky cleanup. During my initial overhang test, the print actually did pop off the bed, which, to be fair, is to be expected when testing overhangs, but the resulting spaghetti ended up getting into all the different belts and pulleys and mechanisms, and then grinding themselves into the pulley teeth even further. Fortunately, things kept running very smoothly after that, and I think that this problem could be pretty easily solved by just shipping a brush, or better yet, a combination brush and scraper with this printer so that cleanup isn't such a big hassle. What are the drawbacks? While we're on the topic of drawbacks, let's talk a bit more about some of the challenges that LDO and Kralin have faced with this printer, and what that means in terms of the drawbacks that you'll experience in the final product if you pick one of these up. First, there's the oozing issue. When a print starts, oozing is a major problem. And this doesn't interfere with bed leveling since there is a separate bed leveling sensor, but it can interfere with your first layer. I'm not sure what the solution could be for this, as it's probably something to do with the 90-degree hot end and thermal expansion. I can't help but think that this could probably be solved by something as simple as just adding a series of gradual retractions as the extruder heats up right into the print start macro. Or better yet, you could add a simple silicone brush to the corner of the bed, similar to what the Bambu Lab A1 series has. Second drawback. In my testing, I found that the toolhead CAN bus cable can get stuck under the gantry, which is a recipe for disaster. Now this can be solved by clipping or zip tying it to the Bowden tube or just tucking it behind it, but ideally I would like to see this kit shipped with a cable that is closer in length to that of the Bowden tube and included clips, since zip tying isn't really aesthetically pleasing, and more importantly, you can't remove it every time you need to fold down the printer, which you do need to remove the Bowden tube and CAN bus when you fold the printer. Third, while the motion system is certainly capable of quite fast printing, it does seem to me like the heater block may be underpowered for actually taking advantage of that speed. When I tried to print PLA at 220C, the heater block exerts 100% power, but it still can't actually reach 220 because the rapidly flowing filament is just wicking away too much heat. So it gets stuck at 215 or 216, and if you go too fast, it can actually drop down even further, causing the firmware to shut down the printer. Now, printing at 210 does seem to solve this issue, though I suppose you could just also slow down. I also, in all my testing, have actually not been able to get it to print PETG for the same reason. It just cannot maintain a temperature of even 240 degrees C. And that's a really, really big deal and a deal breaker if they want this printer to reach its full potential for printing functional parts. This is a pre-production unit, so I did let LDO know about that issue and every other issue that I've discovered with this printer. So hopefully they'll be able to get it fixed before these go into actual production. But Jason at LDO did let me know that they've been testing this hot end for about a year and it is completely reliable for them. So it also may be user error or just a one-off issue with my pre-production kit. So I hope they fix that. They'll fix that. They've got to fix that, right? Fourth, there's the issue of replacement parts. To make this printer perform as it does, LDO and Kralin have had to rely on quite a few proprietary parts. Unlike a Voron, which is mostly off-the-shelf components, this has both a completely custom-made hot end and a custom heated bed, as well as some CNC'd aluminum parts. And that's fine if it's done in the interest of creating a better product, as it certainly has been here. But if you're a true RepRap purist or you're concerned about becoming too dependent on LDO for replacement parts that they may decide to discontinue, you might just want to wait until third-party replacement parts become available. Assuming, of course, this printer is enough of a commercial success to actually justify other people creating them. And fifth, there's the price. LDO is planning an MSRP of $700 for this kit, and that's, at least at first glance, a pretty steep investment for a printer that you need to 3D print and assemble yourself, especially when you can pick up a similar, kinda, Bamboo Lab A1 Mini for just $299. But I don't think that these two printers are actually competing for the same market segment at all. And that's actually a great segue into who is the Positron for, and why is it such a big deal? So who is this printer actually for? And should you buy one? Well, I think that there are a few obvious and then a few less obvious demographics that will probably want to pick this printer up. First of all, if you're the Voron type, the kind of person who loves building a 3D printer from a box of parts, and you want to explore the cutting-edge innovations that had to happen to make this 3D printer, you probably don't need me to tell you that you're going to want to get one of these. Second, if you're someone who needs a truly portable, reliable 3D printer that can weather the abuse of being thrown into a taxi every day, I genuinely do think that this is the 3D printer you've been waiting for, especially if and when LDO begins to offer a plug-and-play version. Whether you're the type of person who travels for work but wants to maintain their hobby on the go, or someone who actually needs to 3D print for things at work on the go, this printer offers an unprecedented level of freedom and portability, which will take 3D printing to places it's never been before. At the beginning of the video, I made the very bold claim that I think this printer might just change the world, and I stand by that. See, while I don't think that the Positron is going to really move the needle of hobbyist 3D printing for people like you and I do think that there is going to be a huge market for this 3D printer. And given the amount of time and money that LDO has invested into developing this product, I'm pretty sure they agree. Now, here are a few examples. I want you first to imagine an aid worker, or a doctor, a veterinarian, or even an engineer, or really any professional who travels to remote places in Asia, Africa, or South America, from village to village. It's easy to think of a lot of different ways that those types of people could benefit from being able to literally 3D print the exact replacement part or prosthetic, cast, or even container that they need for a specific problem. Companies like DJI and Zipline have been valued in the billions of dollars because they offer the potential of being able to quickly deliver things like medication or crucial replacement parts to remote population centers in the developing world. But imagine being able to 3D print them on site, whether that's a village, an oil rig, a boat, a jungle, or even the front lines of a war. With this printer and perhaps a solar panel and battery setup, you could do just that. And I wouldn't be surprised if governments, militaries, and NGOs actually become the primary customers of this printer and the future generations of it. As for the price, yeah, this printer isn't cheap. But I think it's really important to remember two things. First, DIY printer kits in general, and LDO printer kits even more so, are not competing on price. They're cutting-edge tech, competing on quality and targeting an entirely different audience than mass-produced printers from the likes of Bambu Lab. With that frame of mind, the price makes a lot more sense, and in fact, this printer at $700 for the complete kit is competitive with LDO's current Voron 0.2, but offers a much larger print volume and the huge added benefit of being fully portable. The second consideration is to remember that it's still very early days for these types of kits. Just as the first laptops, or maybe more poignantly right now, the first generation Apple Vision Pro, were wildly expensive, heavy, and suffered from imperfect performance, the Positron V3 is, despite its name, the first of its kind to be commercially produced for a wider audience. I have no doubt that if this product is successful, there will be future revisions and upgrades and improvements that both drive down the price and weight while driving up the performance. But in order for that to happen, enough people have to be willing to put up with a few hiccups and signal their interest in owning such a printer by actually buying it. Conclusion. As for me, I'm really happy that I now own one of these, and I'm pretty confident that even if I'd had to buy it with my own money, I probably would have, just to be able to have a printer that can travel with me on trips or the frequent weekends to my in-laws. But I'd really love to hear what you think about this printer. Would you actually truly have a use for a portable 3D printer, or is the price just too high to justify it? I'll see all of you down in the comments to discuss. And hey, if you want to see more content on the Positron or some of the upcoming 3D printers and projects I'm working on, and you feel that I've earned it, I would really love it if you hit that subscribe button and maybe even the like button while you're down there. We're giving away over $5,300 worth of 3D printers and upgrades, including a full LDO Voron kit to over 30 different subscribers at the end of the month, and you definitely don't want to miss out on all of that. Before I let you go, let me just take a quick moment to thank our Patreon and YouTube members, particularly our Nylon and Peak members, Chip Cox, Two Crazy Ketos, Amir Chen, Don Arledge, and Chris Miller. You guys rock. That's all for this week, but I'll see all of you on the next layer.